Thank you very much. Good morning to all of you guys. I am here from Danske Bank. We are based out of Copenhagen. We are one of the largest banks in Denmark and in the Nordics in general. We're a retail bank, and I'm here to talk about our journey with productionizing machine learning. And just to give you a little bit about myself. So I'm Subu for the guys who definitely don't want to pronounce Subramaniam, Ramasubramanian. Thanks really for taking the effort to pronounce that. And I've been working as a data scientist in Danske Bank for the last 4 years. And it's been an exciting journey for us working with the big data platform and with Spark. And if you were to really summarize, OK, what can you take back from this presentation in the next half an hour? It is one possible way to get machine learning to production really, really fast. This is not the only possible way. This is not the best way to get all different types of scenarios into production, but this is one possible way to get something into production very fast. And this is what is working for us right now. And I can see that this is a very recurring theme in this year's Spark Summit. When I was running through the schedule, I was like, OK, there's a lot of people who are going to be talking about productionizing machine learning. There's at least 3 different talks that I went to see, OK, am I going to be presenting something that's overlapping with someone else? This is something completely new. And then I looked at the schedule again to realize that I was going right before lunch, and maybe that should be the thing that I'm most worried about. But I'm very glad to see that there's quite a big turnout. So before we go ahead talking about our journey and all of these things, I think it's essential for us to know what the context is. Where did we come from in the bank? And for this context, I think it's necessary for us to take a look at the infrastructure that we work with, a very, very simplified version of the infrastructure. So we are an on-premise system completely, and we have a bunch of different source systems. So it can be files, it can be SQL Server, data warehouse, it can be the mainframe systems. We move in data from the source systems to a Hadoop data lake. And we access the Hadoop data lake basically through some edge nodes, or basically these are jump hosts that we connect to the cluster from. And we have a bunch of different clients installed on these edge nodes. And once we use these edge nodes to kind of do the operations that we're doing on the Hadoop data, then we basically use web services or straight through processing to either process them straight through or produce visualization on top of what has been done on the cluster. And if you look at the different roles that actually work on this platform, you have the data scientists, the data engineers, and the platform engineers. And over the past few years, I've learned that these words mean very different things for different companies. So I thought it would be fun for me to say, OK, what is it with respect to Danske Bank? And I said, OK, let's look at the tools that they work on and the questions that they ask themselves on a daily basis to kind of get an understanding of what data scientists mean in Danske Bank, what data engineers mean in Danske Bank, and so on. So as far as the data scientists are concerned, they work primarily on, we work a lot on Python. So Jupyter, Spark, and Hive beeline clients. So this is basically what we're working on. And the kind of questions that we end up asking a lot of the times is, what is the scope for data science in a project or analytics in a project in general? What kind of model should we be building? What are the metrics that we should be looking at? And until a few years ago, we were also looking at, OK, are we actually going to do all these things? Or are we just going to do data cleaning for the rest of forever? The data engineers, they work on ingestion tools primarily, so Scoop and scheduling tools, Uzi. And the kind of questions that they are going to be asking are, OK, are there any reusable data products, reusable transformations? And is the data validated? Is the data actually moving into the Hadoop cluster from the source system? So these are the kind of questions that they're asking themselves a lot. And sometimes we also have to remind them that validation is also something that they shouldn't forget. As far as the platform engineers are concerned, these guys are the provisioning guys. So these are the guys who upgrade the cluster. These are the guys who work on the cluster management interfaces. So the kind of questions that they ask are, what queue should a particular job be running on? Will upgrading some tool break existing jobs and flows and stuff like that? And these are the guys who are going to be working on things over the night to get them up and running if they do stop at some point of time. So how does this synchronize over all of these different roles? So we have the platform engineer provisioning a platform for us. So we only have one cluster. So when I say provisioning a platform, it's not bringing up a whole cluster, but this is more bringing up the edge node infrastructure for the data scientists and the data engineers to work on. And then the data engineers move data from the source systems to the landing zone, which is part of the data lake. And then the data scientists do some of the analysis that they have to do, build models. And once these models are done, this is where it got a little tricky. We had to make a really difficult decision as an organization, which was, are we going to spend all of the time to re-implement this in production-ready code and then move it to production? Or are we just going to build a wrapper on top of this and say this is production and just schedule it? And we chose the latter because we wanted to reduce the amount of time that it takes for us to go from data science to market. And so that's what you see here. And then the data engineers schedule it on the queue that was configured by the platform engineers. And then the platform engineers will monitor the jobs once they've been scheduled. So this all looks nice, but what happens if there's a problem in the job that is actually running? So the platform engineer has no idea what job this is. He has absolutely no idea. So he's going to say, hey, there's something that's gone wrong to the data engineer. And then the data engineer is going to look at the wrapper and see if there's something wrong with the wrapper. And if there's nothing wrong with the wrapper, he's going to say, OK, everything seems to be running fine. The scheduler is running fine. Maybe it was the data volume that increased. It could be because of any reason that this failure happens. So he's going to send it back to the data scientist. And the data scientist doesn't even know what the production table is because he doesn't have access to the production environment. And then he's going to look at the landing zone, and you can see where this is going. So if you really wanted to boil down the core of the problem, everybody knows there's a problem, but nobody really knows who should be fixing this. And this is where we want to introduce FlowSpec. So before we go into the details of the actual tool, we kind of wanted to boil up what is the abstraction of the problem that we're looking at. So the data scientists these guys are mathematicians. They are not software engineers, so they could not care less about distributed computing platform or anything like that. They basically work on the functional transformations. This is what they are good at defining. And the data engineers are the ones who can take care of the robustness, the scale. These are software engineers. So this is what they're going to be looking at. And the platform engineers are the provisioning layer. So they're going to be bothered about configuration, version management, stuff like that. So how do you abstract each of these layers? So you can abstract the functional transformation definition into Spark pipelines, and the robustness and scalability and maintainability part into the configurations that you pass into the Spark data frames before they're being saved. And the configuration versioning, of course, is the Spark Yarn or Mesos or whatever cluster management, resource management tool you have. So what does this look like when you implement this process into a kind of a tool or a UI, and what does this look like? So this is where I would like to cut to a demo, which will hopefully work. So before I go, OK, this is what I thought would happen. Yeah, so this is the Jupyter Notebook interface that we use. And OK, I'm going to be looking there and actually doing things here. So that's going to be very challenging. A little bit bigger, sorry. Yeah. Yeah, I think that's better. OK, cool. For those who kind of don't really know too much about the pipeline infrastructure in, or API in Spark, this is a very short demo of that. So basically, the idea is that you have a data frame that is defined like this, let's say. So this is a very real-looking table. It's completely production data, believe me. And so you have some of these columns on this data frame. And let's say that you want to create a month column from this date column that you see here, this transaction date. So you just define this transformation, which says, OK, get me the substring of this transaction date column and the first 7 digits of this, and from an arbitrary table. And this you define as a SQL transformer. So And then you can basically use this transformer and say transformer.transform of this data frame, which is the abstract representation of the data. And this has now magically appended a new empty column. And if you were to actually say show on top of this as well, it will actually print out what the value is. Which is, of course, taking a little bit while. Yeah, so you can see that this is now the first 7 digits of the transaction date. So you have a bunch of pre-existing transformers already available in Spark, which you can completely use. And you can also build your own transformers completely from scratch as well, either in Python or in Scala, completely fine. And so if you were to use this as a data scientist, if you were going about, let's say, looking at the data. So let's just take a look at the data, see, OK, we have 3 different tables. Let's just look at the last one that we've been looking at as well, which is the transaction table. So you have a customer ID and account ID, the transaction date, the date on which the transaction happened, the amount, and a spend category, let's just say. So now let me just import some of these very nice libraries and say I want to define a flow that kind of uses this data and produces something nice. So I'm going to create a DT ag, which is basically the month part. And then I'm going to use my aggregate transformer, which is basically a glorified group by. So it's going to do a group by on all of these columns and then produce some statistics on this column, which is the transaction amount. And then I compose both of these transformers into a pipeline, as you can see here. And then I just say, OK, transform my transaction data frame. And you see what it has done. It's basically produced a monthly group by and the sum, min, max, count, standard deviation of the different transactions in that data frame. So now what I can do is I can ship this as well. So this pipeline that I just fit, I can basically write this to HDFS. And then, yes, you have a functional definition abstracted away and saved into HDFS. So I also go ahead and define another flow. This is going to be importing, doing the same thing on a yearly basis instead of a monthly basis. And I can show you what that will look like. And then I save this pipeline into a yearly ag flow instead of a monthly ag flow. So, and then I can go on and say, OK, I'm going to put some unsupervised learning on top of this. I'm going to define some columns that I want to cluster. And I will create an assembler that will basically assemble the columns that I just defined here into one single vector, and then do some standard scalar operation on this, and then fit a k-means model on top of this, and then make this a pipeline as well, and fit this pipeline. So once I fit this pipeline, I have my model, and I can see if I use this model and do a transformation, what does that look like? So here you can see that it did all of my existing operations, and then it basically produced a feature vector, and then did a standard scalar operation on this, and then produced basically a bucket corresponding to each of the monthly aggregates of the transactions. And I will save this to HDFS as well. So now the data scientist is done with this work, basically. He has created functional code that works, and he has tested it. Everything seems to be running fine. So now the data engineer comes in, and he's going to start using FlowSpec. So he's going to say, OK, this is just a base directory for the FlowSpec to start working on. So this is basically where the configuration files are going to be stored. And I initialize this, and then I can say, OK, what file do I create? I create a test file. And what is the input table? So I can plug in an input table here. And then I can also put in an output table. And then I can say, so the input table is my raw transaction table, and the output table is just any table that I want. And then I say, OK, what is the transformer that I want to use? It is this transformer that I just saved here. So this is my monthly ag transformer. And then I also say, OK, do I want to do an overwrite, or do I want to do an append? And you can see that there are many more configurations that he can pass. So he can say, what column should I be partitioning this by? What column should I be clustering this by? What is the file? What is the file format? Or should I use ORC, Parquet, should I be refactoring this data frame before I start using it? Should I cache some results somewhere in the middle? So all of these things which are related to the distributed computing aspect of Spark are configurable parameters that you can pass, and the data engineer takes over this configuration basically. And once you do this, you can just you can execute this and it will save it. And I've already gone out and saved all of the flows for the yearly and the monthly transformers. So I'm just going to say, okay, now if I want to use this, I can say, okay, get me the details for this output table, the flow that kind of creates this output table. And you can see, okay, this is the output table, and the input table is here, and this is the transformer. And it also goes to Hive and says, okay, give me the details of when this table was created, when was it last updated. So just a little bit of extra information. And you can, if you want to run this flow again, you can just say run current flow. Or you can, okay, this is when things got really interesting. We had made this really nice API to do all of these things. We said, okay, there's data lineage in here. I have a bunch of configuration files that say what the input table is, what the transformer is, and what the output table is. Let's actually do some data science on top of this as well, maybe. And we said, okay, let's draw a UI on top of this. And then you see, okay, this is my source table, and it is used to create these two, so that both my monthly aggregation and yearly aggregation are here. And then I join these to create my cluster in. And then I have a k-means flow running here to create my cluster out. And this was very nice for us to use, because it's not as simple as this all the time. I will show you a screenshot later on, which is basically what I see on a daily basis. But what more can you do from here? You can basically say, OK, give me the details of the last flow. You can see that this table has not been created yet. As can be seen here, it couldn't find the table. You can also say, OK, get me the dependencies for this table. And it will say, OK, these are the 4 tables that are the dependencies. And it's not doing this blindly. It is looking at the update timestamp of each of the tables' source table. And if it is greater than the update timestamp of the existing table, then it will say, OK, this is something that you need to refresh. So what does this mean? So here you see that this is the end result table. This is the last table. It says all of these flows need to be run. So this table, this table, this table, all of them need to be updated. So now let's say that I go here and I load the monthly aggregation, and I say run this flow. So now what it's doing is it's basically running the monthly aggregation flow and updating it. So you can see that here the timestamp is 21, second of October. Now if I reload this, now it's updated. So now it's the current date and time, as you can see. And if I was to go back here, load this flow, and then say get dependencies now, you can see that that table has been removed. Only the 3 other tables need to be updated, because this one has already been updated recently. So you can also save a tremendous amount of effort, updating updating flows that you don't need to update, and you can also focus on the flows that you are interested in, and not really have too much of a bother about, okay, am I using this for some? Am I using a source table somewhere else? Does that need to be updated? You don't need to do any of these things. So not just in a production flow, I use this quite a lot in the development flow as well, in the end. So if you go back to the presentation. So what does this look like? So some of this is, so these are the configurations that you can actually configure. We actually had this running in a beautiful UI, and the UI kind of stopped working yesterday, so we had to do something else. Kind of proves my point. Data scientists are not software developers. We shouldn't be doing stuff like this. So this is what it looks like on a regular basis. So this is, so you can see the sheer number of different, you can see the sheer number of different sources that we work on, then different flows, and we can say, okay, there is a flow, there is a model that I'm training using this data, so then I need to refresh that and not really care about all of the different dependencies. I've already done this once before. So this is kind of what it looks like on a daily basis. And this is just one guy working on this. If you were to move all of your flows into this configuration, you would have a diagram that spans your entire set of data flows or data warehouse. That kind of gives you a very comprehensive picture of where your data lineage is. So talking about the future work, we of course want to include, so one of the things that I kind of failed to talk about a little bit is the validation part. So you can see here that there is a mandatory columns part. I will show that to you guys here as well. That's the mandatory columns part over here. And this is a validation that, that the FlowSpec engine does. It's basically going to check if this validation, if these columns exist in the input table before before it tries to run the flow. And this is very essential because one of the most common excuses that we get from the platform team or the data engineering team is that we don't understand Spark errors. Is just too cryptic for us. So we said, OK, let's do validation separately and then say, OK, if there's a validation issue, then it will show up as a validation issue. It won't show up as some null pointer exception from God knows where. So you don't have that. So one of the things that we would like to do is, right now we just have it for to check if the columns exist. We also want to do distribution checks. So we want to be able to say, is there a particular column which is not supposed to have null values? The distribution of of values in a particular column should be within this range. We want to be able to say validations like this and incorporate it as part of FlowSpec. And we also have a command line interface just like the API. And we want to make this a little more robust so that it can be plugged into different types of schedulers, basically. And the next one is a little bit more tricky. We want to create a culture against creating custom transformers. So purely in PySpark, this is supported only from Spark 2.3, I believe. And otherwise, you would have to write the Scala transformers and then create wrappers in Python. And yeah, so this is a bit of a contention. Because they don't, the data engineering team doesn't have Scala resources, then they come back to you and say, hey, we can't do this. So we kind of want to create a culture both in the data science teams and the data engineering teams on creating custom transformers to kind of say, okay, these are transformations that we keep doing often, and let's figure out the most optimal way to do this, and let's actually implement this as something that people can reuse. And another one that is a little difficult for us to address is how do you push for data scientists to stop writing stream of conscience code like they usually do in a notebook and go from there to writing things in Spark pipelines. That's another tricky one. But yeah, I hope that once we fix the custom transformers things and we make it easy for people to write code in pipelines, they will naturally adopt this a lot better. And of course, we're also trying to see if we can make FlowSpec open source so that people can use it and also contribute back. And it becomes a more open atmosphere for us to work with. So just to summarize, use Spark pipelines. This is a wonderful way to abstract transformation information. And the data scientists, when they work with this, they are only dealing with the functional transformations. And aim to reuse code using custom transformers and optimize these custom transformers so that your reusable code is working in the best possible way. Simplified distributed computing for data scientists. They really do not get this stuff. And I know it makes it, and if they do get this stuff very well, then they end up becoming too expensive and move on to other companies. So it's good for your company and it's good for the community as well. Try to make it simple for the data scientist and streamline the entire process with a tool like FlowSpec. FlowSpec actually took the first version of FlowSpec for us to get up and running. It took us 2 weeks of just sitting and coding up something to get it working. The process is really what I'm trying to say worked beautifully for us. The tool it's really immaterial. I'm pretty sure that if a bunch of developers were to sit down and try to recode this, they could do it in no time. So thank you very much for coming and listening.
We have some time for a few questions, so if the floor is open. Hi, thank you for an interesting presentation. I had a question about the process you drew at the start there. You described data scientists' output being wrapped. Does that mean that they write something in Python and then it's kind of converted to some other format, like a Spark job?
Okay, one of the advantages that we had in Danske Bank is that the data scientists are kind of required to write Spark code. So they will write it in PySpark, but I mean, it's really stream of conscience code. They will give you notebooks if they must. I really strive to push data scientists to look a little bit further than just notebooks. And so what the platform team and the data engineering team will do is they will give us a framework where they'll say, okay, there are these classes, you have to implement these classes and implement these methods so that it's a little bit more streamlined for them. So these are the wrappers that I was talking about.
And those are in Scala, Java, or Python?
Python.
In Python, okay.
Yes.
So you're giving them a Python framework.
Yes.
And they have to use that framework.
Yes.
Does that framework work in, say, Jupyter then?
No. So this is, I mean, they could test it out in Jupyter, but it's built for execution from command line. So you would have to extract the relevant parts of your code from Jupyter, put it in a .py file and in classes, and then make those classes inherit the framework classes, and then put the code in the appropriate methods and stuff. It's a lot of work for the data scientists to kind of make it conform into this framework,
Okay.
basically.
Thank you.
Yeah.
Any more questions? On my way.
Hi. Yes, the question is about the usage or potential extended usage of Jupyter Notebook. Mm-hmm. I'm an extensive user of Jupyter Notebook and following developments wherever. And when Netflix, for instance, is tackling a similar problem, and it's actually extended the usage and making the Jupyter Notebooks executable pieces of code of specification. Such a way, when something fails, all the information is packaged nicely in a specific place, and the data science can have a look to it. They don't need to do any magic or convert, whatever. And the second thing is, Jupyter's got one thing which is called nconvert, which is kind of for this thing, in such a way that you can automatically extract the Python code and make it executable. Yeah. Have you considered any of those approaches?
Yeah, we did. The reason that we couldn't directly take this up was because, I mean, yeah, it's Python code that is inside Jupyter Notebook. You could just take the entire thing and dump it in. The problem was the tables that we worked in as data scientists were not really the same a lot of the times as the tables that the job that's going to be running production flows are going to be. So the data engineers kind of wanted to be able to plug and play flows with different tables. So we would get a copy which is a subset or a one-to-one copy of the production tables, and we would work on this. And then we would give the flow back to the data engineers, and they would need to run it on a different table that the data scientists don't even have access to. Yeah. So we can't just take any code that has hard-coded, everything is hard-coded, and then say, okay, here is the code. The data engineers are going to be like, yeah, okay, cool. But yeah, this is kind of the reason for the creation of the framework.
Thanks.
No problem.
Well, one more question. Sure.
It's a very short one.
Yeah.
The Danske, do you have some plans to go to the cloud?
Plans to move to the cloud?
Yeah, because the whole application, I think, is on premises, right?
Yeah, so I think we have a very strong stance against the cloud right now. Hopefully that will change at some point of time, because I think there's quite a lot of interesting things happening on in the cloud, and a lot of our time is being spent on provisioning and things like that. And but I mean, the key concern has of course been security, data security, and these are the primary concerns that we see quite a lot. I'm not sure what the roadmap is going forward, but for the foreseeable future, I don't really see them moving to the cloud anytime soon, but maybe.
Okay, thank you, Subramaniam. Sorry. Let's give a hand for him.